Hi, everybody. Welcome to my Introduction to Mathematica videos for my Intro to Linear Algebra course here at Mississippi State University. Over the next 5 videos or so, sorry, let me adjust my camera. Over the next 5 videos or so, we are going to take a little dive into how linear algebra works within the Mathematica system, and then what types of problems and what type of topics would I expect you to be able to complete on a project that you will have to complete by the end of the semester. Now, before I get going, one thing to keep in mind is that these videos are meant for you to watch at your own time. We will be covering all of the material that you see in these videos in class in a more simple idea where we can actually do things by hand. But as you've probably learned, not only in your math classes, but in other classes you're taking, a lot of topics in mathematics and applied math can't be done by hand. So we need a way to compute them in a quicker way. Now, while there are many math programs out there, the one that we use here in the math department is called Mathematica. And so in these series of videos, like I said, we're going to take a deep dive into how linear algebra can be done in this system, and then obviously doing some practice problems and getting you ready for your end of the year project. So what I want to begin with is I want to show you where you can download Mathematica for free since you are a Mississippi State University student. Then I also want to talk a little bit about the basics of Mathematica in this video, and then we'll kind of wrap up this video by showing some introduction to linear algebra. So how do you define matrices and all that good stuff? And then that'll put a bow on this first video, and then I'll kind of get us ready for what video number 2 will do. So let me begin by sharing my screen with everybody. So we're going to share Chrome here. Oh, let's actually share the whole screen. All right, so as you can see on the screen, I went ahead and I am currently on the ITS website for Mississippi State University. So if you don't know how to get here, you can see the web browser at the top of your screen says its.msstate.edu. Now, if you would like to work on Mathematica on your own computer, what you will need to do is follow the next steps. We're going to go under the software tab here at the top. And then you'll notice that Mississippi State offers a bunch of different softwares to its faculty, staff, and students. What we're looking for this class is to scroll down to where it says Mathematica. Now, do notice that this only works for Windows and Macs. If you happen to be running a Linux operating system, this does not work, but I don't see many students who run that operating system. But if you do, you won't be able to download this on that computer. But if you click on Mathematica, as you can see, we are currently in version 14.2 for the university. That's not the version that I run on my laptop that you're about to see, but they all are pretty close and they all work the same in the end. If you are looking for the instructions in a PDF format, you'll see down here at the very bottom, there is installation instructions for your Windows if you're running that operating system, or if you're running a Mac operating system, there's the installation instructions there. Once you download that so you have it to kind of follow along, all you have to do is you'll click on the student use link, and then you can go through this process where you can agree to the terms, you can download it, and then go from there. And then once you follow those instructions, you will see that you are going to get, I'm gonna actually accidentally already opened. Let me close it. You will get a Mathematica system. Now, as you can see, I'm not running version 14.2. I do on my office computer, but I'm making these videos at home, and on my work laptop / personal laptop, I'm running version 13.2. Nothing I've seen will make a major difference between these two versions. Everything that I do in version 13 still works in version 14, so no issues there. And so what I want to show you in this video is kind of, okay, what does Mathematica do? And then like, what's the purpose of this? And then kind of the intro to linear algebra part. So Mathematica is built with knowing C computing language. You do not have to know C in order to be successful in this. I'm going to show you everything you need to know. But what we will do is we're going to actually work within what Mathematica calls a notebook system. So I'm going to click on New Notebook. And then I'm gonna enlarge some stuff so it's a little bit easier to see here. All right. And so this is what's called a notebook file in Mathematica. Now, there are a bunch of different buttons and tabs you can see at the very top. I encourage everybody to explore those and see what they do and what can help you do certain things. Some of those you will never use in this system because there's some of them that I don't use in this system, but there's so many things within Mathematica that I encourage you that if you have time to mess around with this, because this is probably not the only class if you take all your math classes at Mississippi State where you will be using Mathematica. We use this system in our Cal 3 classes, which if you are in my Cal 3 class, you will see a different set of videos kind of tailored more towards the calculus lens. A lot of our Calculus 4 classes use this system, and so do our differential equations classes. So this is not going to be a system that it's a one and done. You'll probably use it a few different times. Before we get to the actual coding part of this first video, I want to show you a couple of things that are within Mathematica that might benefit you as you're working on your project for the end of this semester. So the first one is called a math palette. So under the palette tab at the very top, you'll see a bunch of different options here. The one that I prefer to use is under the other symbol. And then there's one that's called basic math input. And so as you can see over here, it opens up a file that has a bunch of different built-in codes that might be of use. Now, I will say I don't use a whole lot of these in linear algebra coding because a lot of the codes are a little bit different, but especially if you're a student who's also in one of the calculus classes and you're doing this, I use a lot more of these built-in codes for that. But occasionally you will hear me say, hey, let's use the math palette to do this. This is how I'm getting to it in case yours closes at any point during your project. So I'm actually going to close it for right now because I don't think I'm going to use anything on here in the first video. The only thing that I might come back and show you is this matrix button here. But the problem is that it's only built for a 2x2, and a lot of the matrices that we're going to look at are larger than that. So I'm going to show you a different way to input matrices. The one that I do want to show you all, because I'm pretty sure a lot of y'all will use this, is kind of like the Google search of Mathematica. If you go under the Help tab, which is the very last one, and you click on Wolfram Documentation, this is essentially what I tell students is the Google of Mathematica. You can type any keywords you want to, and Mathematica will see if they have a built-in code or if they have a strategy for how to tackle that idea. So, for example, you're in linear algebra, so let me type in an idea that we do in linear algebra. So we may not have gotten to this point yet in lecture. If we haven't, like I said, it's okay. You'll get to it eventually. But we do the idea of determinants. So we do a whole chapter on determinants. And so what I would do is I would search the word determinants in Mathematica in the help feature. And what you will see is there's a bunch of different ways that determinants are done within Mathematica. There's the basic find the determinant. Some of y'all might have already taken or are currently in differential equations. We do Wronskians in that class. It has to do with determinants. That might be useful. And then I'll be honest, I don't know what all these built-in codes do because I don't use them all on an everyday basis. But like I said, you can go through and you can read, and there's a brief description here of what each of them can do. Now, if you want to dive deeper into each of these, so let's say just the very first one, if you click on that, what you will see is that it opens up not only how to code the determinant of a matrix, it also gives you examples and it shows you exactly the coding process, whether it be doing it with a symbolic matrix like a 2x2 or finding the determinant of an exact matrix that may be larger than a 2x2. You can also go down here and see different applications that might be of use. And so I encourage you to explore that because it may be very useful for what you need. One thing to note is that you do need internet access for this to work. So if you're not on the internet, it will not work. So make sure you're either on Wi-Fi or if you're Ethernetting into a system. So let me close that here. So now that we know where those two things are, what I want to do is just in this first video, show just a couple of basic things that apply to linear algebra. So as you watch this video, each person who watched this, we may be at a different point during lecture. So keep in mind, if you hear me reference something that we have not covered during class yet, it's okay. We will eventually get to it. And I'll try my best to reference chapters when I mention different topics. That way you'll know if we've gotten there or not in class. But for this video, the first thing I want to begin with is, okay, this is linear algebra. The number one thing is we do everything, and it's the mathematics of matrices. So how do we define a matrix in Mathematica? Well, let me show you the most basic way to do that. So what we will do is over here in our coding line, you'll notice that we have a line that is running horizontal across the top. There is a plus symbol right next to it. Currently, you are in a coding line. So anything that I type in right now will be Mathematica trying to interpret the code. When you start reading the instructions of your project, you'll notice that some of the instructions say, type in your description before you begin coding the problem. To do that, you'll notice the little plus symbol over here on the left. If you click on that, there is a link that says plain text. And so if I click on that, Mathematica, you can see text here at the top, becomes essentially like a word processing unit. And so I could type something in like question 1, blah, 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 blah. And you could just give me a brief description of the question you're about to answer. I do not need you to type out every detail of the problem. I would just encourage you to do question 1 and then give a brief description of what problem 1 is asking you to do. And then right below that is where I want you to begin the coding. Now we're still in a text line. So if you try to hit enter, it's going to keep you in a text line and we don't want that. So instead, what you need to do is hover right below your text file. You'll see that your cursor is running left to right or horizontal. And if you click, you will be back in a coding cell. And so you'll see the plus sign show back up and you can see the cell little input here at the very top. This is where we will start coding stuff. So back to what I mentioned a minute ago. How do you input a matrix in Mathematica? Well, to do that, you need to first know that we are going to input matrices by rows. So you have to make sure that you do the rows in order for this to work. Let's begin by calling something a matrix A. So I'm just going to use capital A for my notation here. What I will note here at this point is that you can call your matrix whatever you want. I typically call most of mine capital letters because we're going to also do vectors a little bit later in this class in chapter 6, where I will use lowercase letters to represent vectors. One thing to be aware of in the capital letter world is that some capital letters represent something else in Mathematica. For example, you see that my capital A is blue. If you try to do capital D, you'll notice that it's in black text. That's because Mathematica knows what capital D is supposed to do and what the built-in code for that is. So I would encourage you, before you define anything, do not use a letter or a capital letter that is black. It needs to be blue before you begin. So I'm going to go back and do A. So we're going to let A equal. And in order to input a matrix, let's start with a 3 by 3. I am going to open a curly brace. So this is me telling Mathematica I want to begin to open a matrix. Now, since my matrix is going to have 3 rows of 3 elements each, I now need to tell Mathematica what's going to be in row 1. So I'm going to open another brace. And you'll just see Mathematica is reminding you that, hey, don't forget you haven't closed your whatever symbol it may be. And that's okay. Eventually all the orange will go away. So for my first matrix, we're going to keep it really easy here. Let's let row 1 be the numbers 1, 2, and 3, making sure that I put a comma between each number. And then I'm going to close my first curly brace. That is the entries of my first row of the matrix. To start row 2, I'm going to put a comma, and then I'm going to open another curly brace. And you probably can guess what I'm going to do here. 4, 5, 6. Close my curly brace, and let's do one more row, comma, open my last curly brace, and I'm going to do 7, 8, 9. I'm going to close the curly brace for row 3, and then I'm going to close the curly brace for the whole matrix. And so this is how we would define matrix A in Mathematica. I need to tell Mathematica this is what I want matrix A to be. So to input any kind of code into Mathematica, you need to hold down the shift button and hit enter. And you'll notice that watch the capital A here. It will go from blue to black because now Mathematica knows that matrix A is going to be this particular values. Now, what some of y'all may notice is that these are not going to look like traditional matrices that we do during lecture. So what I would encourage you to do, if you ever are not sure you've done something right, we can double check if what I typed in is what I intended. There is a built-in code in Mathematica, I'll go ahead and type it out for you, that is called matrix form, capital M, capital F. If you type in this built-in code, and then you do an open bracket, and then you put whatever matrix you want it to check, and you input this by doing shift enter, it will put it in the more traditional format of what you're used to seeing in matrices. So you can see my first row is 1, 2, 3, my second row is 4, 5, 6, and my third row is 7, 8, 9. So you don't have to use the matrix form key ever unless you just want to check yourself, but especially for beginners in this system or even beginners in this system in a linear algebra lens, I would encourage you early on to do that. And I'm going to do that a lot in these first couple of videos as we check ourselves. Now, we can define as many matrices as we need in the problem. So I'm actually going to define a second matrix. I'm going to let this second matrix be B. So remember, we're going to open our curly brace to open the matrix, and then I'm going to open another curly brace for row 1. And I'm going to use some slightly different numbers this time, so I did write some numbers down before I started this. Let's do 0, -1, 4 for my first row, comma, close your brace, comma, open a new brace. Let's do 3, comma, -2, comma, -1. Close my brace, comma, open my brace, and row 3, let's let that one be -7, 8, 0. Close my brace for row 3, close my brace for the whole matrix, and then I'm going to do shift enter. And then just to make sure this is what I intended, I'm going to double check my code matrix form B, and just kind of double checking 0, -1, 4, 3, -2, -1, -7, 8, 0. Perfect. And so that is my matrix B. So on any problem that you want to just define a matrix, this is all you have to do. In a later video, we'll talk about how to define vectors, but that's not until a chapter 6 topic. So I'll do that in a different video when I cover the information. Now, with matrices, we're going to do a lot over the next few videos. For this first video, since it's kind of an introduction idea, I just want to do 3 major things with these matrices. I want to show you how to add 2 matrices together, how to subtract 2 matrices, and then probably the trickiest thing in this first video is multiplying matrices together. So let's begin with addition. Now that I have defined my 2 matrices A and B, it's really easy to add them. I'm just going to take and type in exactly what I want Mathematica to do. I want Mathematica to add A and B together. And so if I do shift enter, you'll notice that Mathematica gives me the output in that weird syntax. Now, one thing that I see a lot of students do, and I have no issues with this, just know that it's not required all the time, is that if you do not like this syntax, I will have some students by nature or by just kind of what they're used to doing, put the word matrix form around what they want to do. And so if you want to do that, you are more than welcome to add the word matrix form. Remember, you got to put brackets around this stuff. And that way, not only will Mathematica add the 2 matrices together, it will also go ahead and put it in the traditional format you're used to. So shift enter, and you'll see that it went ahead and put it into the traditional 3x3 matrix form. One thing you might have noticed is that all I did was go back to the previous line and add in what I need. One of the nice things about Mathematica is that it already can fix whatever you're doing. And then obviously, if you get any errors, just make sure you're careful about closing all of your syntax whether it be brackets or braces or anything of that nature. Now, we can do the same thing for subtraction. So if you want to subtract the two matrices, I'll show you that you are more than welcome to do matrix form. And what if I want to subtract the matrices A minus B? So Mathematica works from the inside out. It will subtract A and B and then put it in matrix form. And you get this 3 by 3 matrix. Now, like I said, Mathematica is very user-friendly and you can edit things very easily. Let's say you made a mistake and you meant to do B minus A instead of A minus B. Well, simply go into your code that you messed up, fix what it is you meant to. You'll notice that your output is grayed out because it understands that you're editing whatever it is. So please make sure that at the very end, you have to re-enter the code, Shift Enter, and it will fix B minus, or fix your matrix, in this case, to be B minus A. So that's all it takes to add and subtract matrices. Pretty simple. With multiplication, this is where you've got to be a little bit more careful, because in nature, in most students' nature, is that whenever they do multiplication within Mathematica or within any code, they like to use the asterisk symbol. So let me show you what happens when you do that. If you do A star B, which is what most students will ensure, and once again, I'm going to add the word matrix form around this just to put it in the form most students prefer. You'll notice that we have these these 9 numbers. Most students will just assume these are correct. Now, if you've gotten to the part of lecture, which is in chapter 2, where we have learned how to multiply matrices, you can double check this on your own by hand and notice that it is not right. Here's what this code is doing. It is taking the first entry of A, which you can see is this 1 right here. It's taking the first entry of B, which is 0, and all it's doing is multiplying those two numbers together. Obviously, 1 times 0 is 0. But as we've learned in chapter 2, that is not how you multiply matrices. You have to multiply a row by a linear combination of a column of another matrix and then create each entry. So my warning to you all, when you get to the multiplication part of your project, do not use the asterisk. The asterisk is meant to multiply numbers only and functions together. It's not meant to multiply matrices together. So if you want to multiply matrices together, what you will do is instead of using the asterisk, you're going to use the period. So the period is the built-in code for matrix multiplication. So I would want Mathematica to do the matrix form of A period B. And if I re-input this, you'll see that your numbers drastically change. And now you can double check it by hand if you would like. This is the correct A times B. Now, as you know in matrix multiplication, as we discussed in class, the order in which you multiply matrices does matter. So please make sure you put them in the order you want Mathematica to multiply. So if you meant it to go from B times A, once again, easy fix. Go back into your previous code, change that into B period A, and you'll notice the numbers are going to drastically change again, because now you're multiplying them in the order of the matrix B times the matrix A. And so that is how you will multiply matrices together when you need to do that within your project. The last thing I want to show you in this first video is that as you're working on your project, there's going to be problems where you want to reuse some of the same letters you've already used. Now, anybody who's ever taken a coding class would probably tell you that if you start using the same variable over and over, you're asking yourself to get a big issue and a lot of errors. So what I would encourage all of y'all in class to do is, once you are done with a problem and you have the answer that you want, let's clear the variables that I want to reuse again later. And so in this problem, what if I want to use A and B in a later problem? Here's what you would do. We would use the built-in code clear for Mathematica with a capital C. You're going to open your bracket and you're going to tell Mathematica with commas between them what variables you would like to clear. We've only used A and B, so that's all I'm going to clear here. To know if you did this right, do note the color of the text. A and B are currently in black text because Mathematica knows what they represent. If I were to shift enter, you will notice that your letters become blue, throughout the entire problem. It's not going to erase any of the coding you did, but if you try to go back and redo any of the parts of the problem, it will not give you a correct answer. You would have to start from the top and work your way all the way through. So please do not clear anything until you are done and ready to move on to the next problem. If you do realize later on, oh no, I got to fix problem number 2 or whatever it may be, that's fine. Just make sure you have to go through and re-input everything so that Mathematica can update its memory for what everything represents. And then at this point, if you were going to problem number 2, I would do plus sign plain text, question 2, blah, blah, blah. Give me a short description, click below it, and then you would continue on with problem number 2 here. So that is going to wrap up my first video of the 5 video series that I'm planning to do. In this video, I showed you where on the ITS website you can download Mathematica for free since you are a Mississippi State student. We went through the very basics of what Mathematica is. It's overall called a notebook file. And within that notebook file, I showed you where the math palette was. I showed you how the Wolfram documentation worked, which is kind of like the Google search. And then I also showed you the difference between plain text, which all you'll use as your descriptor, and then the coding lines where you can build in your codes. And then as far as the coding, we've learned how to define a matrix now, which we will use in every video from here on out. And then we talked about the basics of adding, subtracting, and multiplying matrices together. So that's going to put a bow here on video number 1. In video number 2 of this series, we're going to start getting into the idea of what matrices are used for. So in video number 2, I'm going to show you all the different ways that you can solve a linear system using matrices, whether that be an augmented matrix or more of a direct route. So I'll see y'all for video number 2.